In this video, I am going to solve the rest 5 problems from exercise for session 3 from Arihant Differential Calculus. Those who have not seen my previous video in solving the first 5 problems from the same exercise, press the I button right now. And I have given the video link in the description box also, so you can check it later on. Let's start solving the rest 5 problems, that is from question number 6 to question number 10. In this problem, to find out the domain of this function given, we have to find out the values of x for which sine of mod x is defined. Sine of mod x is defined for all x belongs to real value. Now, sine inverse tan x is defined when tan x lies between -1 and 1, because we know that for sine inverse x, the domain is x belongs to -1 to 1. Therefore, x belongs to -pi/4 to pi/4. Okay? Now, the period of tan x is pi. Therefore, x will lie between, is it clear to all of you? So these are the values of x for which sine inverse tan x is defined. Now for sine of sine inverse x, it is defined when x belongs to -1 to 1. Is it clear? Now you have to find out the final domain of the function fx, which is the common region between x belongs to r, x belongs to n pi minus pi/4 to n pi plus pi/4, here n belongs to z, right? And x belongs to -1 to 1. Now, if you observe carefully, you will find that if I take n equals to 0, we are getting x is lying between -pi/4 to pi/4. Now, if I take n equals to 1, we are getting x is lying between 3 pi/4 to 5 pi/4, right? Now, this is the values of x which is exceeding x equals to 1. These are all values which are greater than 1, right? Now, since we have x belongs to -1 to 1, the common region will not satisfy this portion. Is it clear? Now, if I take n equals to -1, look it carefully, it will become, now all the values between this region, all values are less than -1, correct? So it is not falling within this range. Therefore, the common region is x belongs to, okay? Now, this is the region which is satisfying the first condition, the second condition, as well as the third condition. Is it clear? Absolutely. Move for the next problem. Here, to define the function e to the power cos inverse log base 4x square has to be greater than or equals to 0. As we all know that e to the power x is always greater than 0 for all x belongs to real value. Therefore, this inequation is always true. The other part we can consider as log base 4x square has to lie between -1 and 1, because we know that for cos inverse x the domain is from -1 to 1, right? So from here we are getting, from here we are having, is it clear? Absolutely. Okay. Now, the other portion is, we have log base 4x square. To define this function, your x square has to be greater than 0. Now, x square is always greater than 0 for all x belongs to real value except 0. Because if x is 0, then it becomes 0 is greater than 0, which is not true. Therefore, the domain for log base 4x square is basically all real values except 0, right? Now, the common region you have to find it from this condition. From this condition, your x belongs to any real value. From this condition and from this condition. So, the common region is x belongs to. Is it clear to all of you? Have you understood it? So, this is the domain for the given function. Clear? Let us move for the next problem. Now, to define the function, first of all, we know that for sine inverse x always lies between -1 and 1. Thus, is it clear? Have you understood it? Okay. Now, for the next one, under root 3 minus x, this is defined when x is less than equals to 3. Therefore, the required domain is the common region between these two, and that will be, so the domain for this function is x belongs to closed -1 to closed 3. Okay. Let us move for the next problem. In this function, we have fx equals to log 3 base 2x divided by cos inverse 2x minus 1. To define the function, number 1, 2x has to be greater than 0. Number 2, 2x is not equals to 1. Right? For these two cases, your numerator log 3 base 2x is defined. Now, to define cos inverse 2x minus 1, we must write that 2x minus 1 lies between -1 and 1. So, from here we are saying x is lying from 0 to 1. Okay. Now, one thing you must remember, since cos inverse 2x minus 1 is in the denominator, so you must take care of it that it should not be equals to 0. Is it clear? Now, it will be equals to 0 when 2x minus 1 is equals to 1. Because cos inverse 1 is 0. So, from here we are getting x equals to 1. That is, we must say that your x cannot be equals to 1 in this case. Because if x becomes 1, your cos inverse 2x minus 1 will become cos inverse 1, which will give you 0. And since 0 is coming in the denominator, in that case your function fx will not be defined. Is it clear? We have to find out the common region between this and this, taking into consideration that x cannot be equals to 1. Now, 2x is greater than 0 implies x is greater than 0, and 2x not equals to 1 implies x is not equals to half, right? Therefore, my required domain will be x belongs to 0 to 1 except half. Is it clear? So, that is the required domain for this given function. Is it clear to all of you? Let us move for the next problem. To define this function, first, tan inverse x to the power minus 1 has to be greater than 0. Number 2, this has to be greater than 0. Number 3, this has to be greater than 0, right? Now, from the first one we are getting, so from here we can say that x belongs to any real number except 0. Is it clear? Because if x becomes 0, tan inverse 0 will become 0 and 1 by 0 will become undefined. So that is why x can take any real value except 0. This is from the first one. Now from the second one we can say, you know why I have changed the sign? Because 2 by pi is less than 1. Is it clear? That is why I have changed the sign. So that implies, reversing it, we are getting greater than 1 implies x is greater than pi by 4. Is it clear? X is greater than pi by 4. Now let us come for the third one. Now from this inequation we are getting that x is greater than infinity. Okay. Now from these three, it is very clear that you won't be able to get any real solution for x. That is, the domain for this function will be nothing but a null set. No domain can be found from this function. Is it clear or not? Okay.